Hello, PCA faculty and Mr. Dean. We did a child protection alarm. So basically, a recent problem or occurring problem that has been in the U.S. and all over the world, it is child dying of heat stroke in a car. So our device is made to protect the child and alert the parent when there is a child in the car. And this is all of our research.
All right, so this is basically just a list of the topics that we're going to cover throughout this presentation. I'm not going to read them off. You can see them right there, but yeah.
All right, here's our problem statement. All right, it's going to be health and safety, legal, technical, educational, and market. All right, boys?
So this was our documentation and analysis of prior solution attempts. So our first attempt, we were going to try to use a LFO eClip baby reminder, and it uses a smartphone to alert the parent when there is a child in the car. Sadly, we weren't able to figure out how this device primarily worked. So our second attempt was a Giraffes Guardian Angel kids tracker, child locator alarm. So this was more or less for to alert the parent when a child gets too far away, but we kind of re-innovated it to be used for a baby and the parent.
All right, so the justification of solutions, designs, requirements. So we're going to start with wants and then needs and specifications, prioritize lists of specifications.
The wants that we need is we want to detect when the child is present, be able to carry out on a keychain by the parents and have a certain hub and connect it to the car seat. The needs that we need to do is we need to detect the child in the car and be able to alert the parent when the child is in the car. Specifications like the car seat device must not be too small and also not too large. The parent key fob must be a similar size to a car key fob. Ringing is to be heard by the parent, but doesn't ring near the child for the main device. Prioritize the list of specifications, able to alert the parent in the car, detect the child that we need to go get the child. Be able to carry on a keychain by the parent in the central hub and connected by a car seat. The car seat device must not be too small or not too large.
Our design concept, generation, analysis, and selection. So our initial brainstorms were a baby key alarm, a baby car alarm, or a baby detector. The design of these concepts were to connect a key fob of sorts to a main device that is in the car. When the key fob was a certain distance away from the main device, an alarm would go off. Our second option was connect the device to the car to set off the car alarm whenever the keys go near a certain distance away from the car. And our last design of concept was connect a device to a weight sensor inside the car seat to sense if there is a child in the car seat, and when the parent walks far enough away from the car, it will set off an alarm.
And the design concept, generation, analysis, and selection. This is basically just our decision matrix of how we chose which design was going to be better, and our decision matrix ended up being the Giraffes tracker.
All right, the application of the STEAM principles and practices. Science describes what materials were used and how to get them. Plastic for the case of the pod, metal that the screw attached the case in the pod. Features materials like durable and rigid. Technology, the fob makes a sound when the cord of the system is more than 4 inches away. Engineering is how to get the final design, and we did some of the math. We determined the distance that the key fob must be from the main core of the alarm to activate.
So the consideration of design availability. So our manufacturing timeline, how did our timeline affect our design? prototype materials, what materials were used, team's prior knowledge and skills, what prior knowledge or skills do we have before we began the prototype, and then outside expertise needed to validate the project is there any outside expertise needed to validate this project?
And the consideration of design viability, existing products for resale. The LFO clip, it's the baby reminder car seat with hooks to your phone, and Dorman keyless entry alarm remote control. It's basically just a key fob.
All right, this is the construction. This is basically our design, what it looks like. The key fob is down here, so this is gonna be on the keys yourself, while the main core is gonna be on the car seats.
So in prototype and testing our data collection, in order to meet our criteria, we want to make the child key fob alarm function with a considerable distance. We did have very few parts to make this possible. We had to run our child key fob through a various testing to ensure it meets the needs of it working properly. So in order to do so, we derived the following tests to ensure that our child key fob alarm works without any problems. We took the key fob and main core and moved the key fob to different distances from the main core while it was stationary to see how far the key fob would need for it to be activated.
All right, in testing data collection and analysis. In testing our prototype, the results were good, but not what we expected. We were only able to get the distance of the set key fob from the main device was only 4 inches, but due to the decreased distance, we were unable to mount it where we had originally planned on the car seat, but we redesigned it to attach near the ignition where the keys would be at, and it would still alert the parent as soon as they take the key out of the ignition. But due to the lack of resources and time constraints, we were unable to increase the distance between the key fob and the main pod.
Sorry.
You're good. Go ahead. It's fine.
All right, documentation of the external evaluation. The project overall went well, but due to limited resources and able to increase the distance of the prototype, we didn't meet the goal of having the main device attached to the car seat.
So our reflection on the design project itself, some prior towards recommendations to others redoing this project where we might suggest more focus and effort. The realization of what is achievable, the specification on what item is what the item is supposed to do, specifying what each member is capable of and what they're willing to try and accomplish, other ways of increasing the distance between the main unit and the key fob, and our justification why these recommendations might have led to better results for us and our team or future teams. Upon our first consideration of the project, it seemed as though we lacked what we needed to accomplish for our project, both physical objects and skill. Occasionally, it was unclear what we exactly wanted for this project to be doing so, where it should be placed, and how long it would be active. And then lastly, if we had given more focus and brainstorming to other ways of increasing the distance between the main unit and key fob, we may have been able to figure out at least a base for a main unit to stay with the child seat and the key fob with the parent.
The presentation of designers' recommendations. Recommendations regarding the conduct of the same or similar project in the future should someone choose to continue your work. Some recommendations that to have a greater distance on the key fob, so more than 4 inches, obviously, and a longer lasting battery. Recommendations on how the project should be improved with consistently detailed plans for the implementation of those improvements. One recommendation is to fix the distance if it can be programmed and change the distance. This project will even be more successful.
So that is our presentation on the child protection alarm. Thank you.